All right, welcome back. I know we've had some snow days, and so we're going to have probably a few assignments that'll end up getting rearranged just a little bit. But what I wanted to start with is we need that clean, sanitized area. And so we're going to work on this project here, the VirtualBox into a virtual computer. So what it allows us to do is create a clean environment that there are some viruses that can get through it, but 99% of them can't breach that virtual environment. It's not a bad way to even operate. I know some very paranoid people that's literally how they operate their entire life, is inside of an environment similar to VirtualBox. But we're going to show you how to use VirtualBox. VirtualBox is a free open source effort, so it does occasionally have some quirks, but again, the project is free, which is really nice. There's a lot of other ones. So if you have a Mac, you can use Parallels and some other tools. If you have a Windows machine, there's VM and a whole slew of other ones that are not free, but we like free because we are cheap, as I like to say. All right, so if you will open up a new tab on your computer, and we are going to go to virtualbox.org. So not only have they updated this and downloaded to a new version 6, which your computers in the lab don't have, or you may not have at home, but it even shows you they're putting in some jobs. But for us, we're going to do this. We're going to click on this big blue button where it says Download VirtualBox. The really nice thing here is this is available for Windows. It's available for Mac, Linux, Solaris if you still happen to have something floating around. And we are going to click, because in this lab we're all on Windows machines. We're going to click Windows and we're going to save this file. That file is fairly small. It should not take very long at all. It took about 2 seconds on this machine to download. So click up again on the Windows host and click and download this installation file. So already there's a couple of things in here that we've talked a little bit about: checksums and making sure your files are correctly sized so that they're not corrupted and have Trojan horses. Here are actually the checksums, so you could compare and make sure that your file is correct. So you need the Windows host up here. So I downloaded it. It's sitting down there in the bottom of my screen. If I had closed this, in most cases you download to the, which window did it pop up in? You download to the downloads folder, and here is that VirtualBox setting there. So I'm going to run this. And my installer is deciding it wants to pop up in the other window, so you guys can't see that, which is always nice. But I will try to move it over as quick as possible. So I'm just going to click Next. I am not going to change any of these default parameters for this installation. And I am going to click Next. I'm going to just leave all those alone. So this will be interesting when you do this. This will kick you off the internet for a little bit when you do this. So what it's doing, it has to go in and grab your network connection, because it's going to create a virtual connection. So when I click yes, it will kick you off the internet for just a little bit. Not going to change anything else, so I'm just going to install it. When your screen goes blank, it's that Windows UAC. So it'll take it a couple of minutes to install. There will probably be another one that pops up. I'm going to allow it to install. So depending on the speed of your computer, this may take a couple of minutes. It may take 5 minutes. It shouldn't take a lot of time. All right, so it's finished its install. And it says, let's start this after its installation. So I'm going to leave that checked because I want to show you what it looks like. And, oh, it is going to pop up over in the other window. So this is VirtualBox, but it doesn't have anything in it yet. This is your containers you're going to build, but you haven't done anything with it. You've installed VirtualBox, and you've got that environment ready to start on some of this, but we're not quite there yet. And so the next challenging piece is we need to figure out what operating system we're going to run. And we said most people in here are familiar with Windows, so we need to get a copy of Windows. So if you're already on a Windows PC machine, and I will assume in here in this lab everybody's on one already, I will show you the easiest way to get your installation file. Right now, there's nothing setting here to run, so we have to go to our next step. That next step is weirdly, and it didn't used to be quite this easy because Microsoft said, oh, no, we want to keep all these files hidden, and we had another way we could get them, but right now, Microsoft, at least today, is saying, hey, come get your installation file for Windows 10. It doesn't mean it's legal or legitimate, but it's giving you a copy here. So if you would find this address, microsoft.com/en-us/software-download/Windows 10. So I'll leave it up here for a little bit so we can show you how to get that. You can also search for it, Windows 10 installation media, and it should direct you here very similarly. All right, are you guys all at this page, hopefully? All right, I'm recording this, so I'm going to keep going so we can get this as close to done as possible. So the first thing we could do is we actually could say, hey, I want to update to the latest version of Windows 10. So we say Windows 10, and actually every spring and every fall, Microsoft releases an entirely new version of Windows. Now, a lot of it's very similar, but it's a complete update every spring and every fall. So twice a year. Windows 10 has been out for many, many years. There's a lot of versions out there. You may want to go on your own computer and say, I need the latest version. You could do that from here. But what we're going to do is I want you to click here on where it says Download Tool Now. So make sure that you notice here where it says to get started, you first need to have a license to install Windows 10. Making sure you do that. We are going to use it in their test environment phase for a few days and work on this method. So you're going to download this media creation tool. I'm going to click save on it. It's very small. So now I've downloaded this Windows Media Creation tool. And this is actually a great advance for Microsoft. Now I can use this tool to make Windows 10 installation flash drives. I don't have to create a disk anymore and go through all these other troubles. Makes life really easy. It's also going to make it really easy for what we're going to do. So I'm going to run this media creation tool. Oop, popped up on the other screen again. There we go. All right. Let me move it over. All right, so it's going to take a little bit of time. So one of the things that we do have an issue with in this lab is we have some capacity constraints. Our campus now has a pretty decent network connection to the world. Our lab, on the other hand, is choked down with like a straw coming out because everybody in here is on a shared connection. So it will take it a little bit to do it. That's why we're going to start this and walk away and start talking about encryption and then come back to this. So I will kind of do some pieces in here. All right. So yes, we really do want to sell our firstborn child to Microsoft Corporation. So click accept. And it'll churn and it'll spin for a little bit more. Here's where we need the Jeopardy theme music going. It's been a long day for you. You have that look. All right. So when you get the screen, aha. So when we get to this screen, we don't want to upgrade the PC we're on. What we want to do is we're actually going to create an installation media. So I'm going to click this radio button, and I'm going to click next. You can actually change these if you need to, but typically it's going to download 64-bit, and it's going to have Windows 10 and English. If I uncheck that box, I can change these. If you're going to change the language, I suggest you use a language that you know. So I would probably not do, so I'm not going to do anything other than English. Even my English skills are, so it weirdly, as a pull down, it only lets you do Windows 10. It used to have some options for some other ones. And most computers today, if you have more than 4 gigabytes of memory, you have 64-bit Windows. If you've bought a computer in the last couple years, you have a 64-bit Windows. So I would leave it at a 64-bit. And we are going to click next. Well, we are going to create what's called an ISO file. So I need to click the button that says ISO file. And an ISO file is literally like a snapshot of a CD or DVD drive. Most of our computers today don't even have one, but that's okay because we're gonna install from it anyway. So you need to make sure you select ISO file, and then we click next again. You need to save this file somewhere not on the desktop in the lab. At your home, you can store it wherever you want to. In here, we do have some lab helpers that like to clean off the desk, which is good, but bad if that's your file. So I'm going to store this one in my documents up here. And I'm just going to leave it as that name, Windows ISO, and I'm going to click Save. And so this is where it's going to take some time because the latest version of Windows 10 is about 4 gigabytes. Well, and we have 8 people all trying to pull data off a tiny, tiny little pipe. It's going to take a while to get there. So notice it's taking a while, and we'll see that. So I'm going to pause here with this step, and I'm going to talk about encryption. Does that make sense? All right, so leave it up in the background, and hopefully it'll get done before we have to run away today. So you'll notice somewhere I have, do I have it up? Nope. Go back. I have too many windows open. I have probably done bad things. All right. Let me go back to my assignments. And week 3. So we're going to talk about cryptography. And so we have a couple of things we're going to do in here. So we're going to assign you these lab simulations. So I need you to get those done by Sunday, the lab simulations, because both of them really are working with some technologies and things we're going to talk about on Tuesday. So on Tuesday, we have a couple of hands-on activities I want to work on, and my boss is actually going to come in and come visit with us for a while, Dr. Borchers. So he's going to come in, observe you, And that's where you can tell him that, I do horrible things and I throw things at all of you, all right? So he will be in here for a little bit, but we need some of these skills ahead of time. So please, please, please make sure you've worked Lab Simulation 1 and Simulation 3-2. Those are those lab simulations. They're not necessarily horrible. There is an assignment this week, and this is part of what we're actually going to do in class Tuesday. So I'm going to move the due date, at least for this particular assignment, over there so you guys can see what we're doing in there. But if you notice what it is, it's working with stenography. And what is our lab simulation? Working with stenography. So you're going to go through some of the very same steps. But what I find is it's a little different when you have to do it by yourself versus doing it through that lab. And sometimes we get a little more hands-on. And we can find some interesting pieces with that. All right. So make sure you have read chapter 3. And I'm going to throw this, there it is. Chunk. So the same view you can have, this is a great, no, I want to start over. So I want to talk about some of these ideas in here. And not do that would be helpful. All right, there we go. All right, so we want to talk about basic cryptography. The idea that, what is it? Why do we care? When have you used it? So when's the last time you guys used cryptography? Huh? Did you guys just log into Blackboard? You used cryptography to do that. Because cryptography is really that idea of we take a message. So in this case, it's those messages from your browser to Cengage's website, from your browser to Blackboard, those messages going back and forth, we need to scramble them up. And we need to scramble them up so that nobody else can read them. I am fairly confident that every one of you has something written somewhere in your Facebook or your phone or somewhere you don't want the entire world to see. So we have to come up with a way that we can scramble that. You don't want everybody to know your credit card numbers, do you? No. You may not want everybody to know your medical history because it's just kind of weird and icky and nobody needs to know all those things, right? So we're going to talk about how we can use this idea of cryptography. And you guys have all done this. I almost guarantee it. When you were in grade school, you actively did cryptography. And so the most common one we do is some kind of a substitution. So if you ever took a note and you said, man, there's 26 letters in the alphabet, and I'm going to write a number behind every letter, and then I am going to take that letter and I'm going to transpose it by putting in numbers, that's really an idea of cryptography. You're turning a note that says, hi, do you want to go out with me, into a set of numbers. And if the other person has that key, in other words, that sheet that you made that says A is 1, B is 2, C is 3, then they are able to take that data and turn it back into your message. And that's really all our computers are doing when we send out a digital signature. So when you see that HTTPS on the left-hand side because you're going to your bank and you want to be safe and secure and you don't want anybody to see that data you're sending back and forth, that's one way we can do that, and we can guarantee it. Now, I will say that there are things like my friend the pineapple here. So, yes, it's encrypted, but it's encrypted to that device. If I can get in between that device, like with this guy, sitting in an airport, so it looks like a Wi-Fi adapter, right? It is. It is a Wi-Fi adapter. It is. But what this allows me to do is go in somewhere and clone Wi-Fi addresses and get in there and use. So I could go blue And while I'm using GoBlue to get my internet, I'm passing it through my computer and then sending it out to the one that we maybe will call fake GoBlue that people will sign on to. And then I have everything that they're doing. So encryption is great, and I'm going to encourage it, but it's still, if you're going into an airport and you're logging on to the Wi-Fi there that you don't know who it is, or you're logging in at some cafe and you don't know anything about it, maybe there's some guy like me that's sitting here going, oops. So we did this a couple years ago. I used something very similar, and I actually went upstairs to a session that we had. We were interviewing for a position on our campus. And we had asked students to show up there, and they did, and I called it fake GoBlue. I had double digits number of students who signed into fake GoBlue rather than the actual GoBlue on our campus. And so after the speaker was done, I took over the projector and I started pulling up on the screen where people were going on their computer. So I'm not allowed to do quite that anymore because apparently there's some issues, but we're going to find ways to create connections, but we have to make sure that both endpoints are secured. So, get back over to my tiny little slideshow. How do we use this cryptology to protect us? Well, it's really that idea that it's scrambled up, and unless you have the key, nobody else can get a hold of it. There are some people crying right now that they have millions of dollars of bitcoins locked in hard drives or somewhere else that they can't get into anymore because they encrypted it, but they lost the key. So if you lost the key to your house, you call a locksmith, they come and they give you another key, charge you a couple $100, and you're back in the house. But the keys that we're going to build and look at here, there's no way to reestablish them. So making sure those keys are securely placed somewhere is important. So cryptography is really nothing more than we scramble stuff up. We take our data that we're sending, we take our information, our message, whatever it is, and we scramble it up. OpenPuff that we're going to use is something called a stenography program. Stenography is the use of hiding something inside something else. So it's kind of like that Trojan horse, but one of the really great things is when we have a big picture, there's a lot of spots in that file for it that we can hide data. So we can take a file, maybe an MP3 or a video, and we can bury information into there. And when you look at that picture, you're not going to see any difference. And maybe we put it in, so depending on how we want to store it, there's slack space, there's blank spots, there's metadata, in other words, data that tells us about that picture. That's stuff you find out when you take a picture and then you go, man, it just has my GPS coordinates and what camera I used and what lens I used in that metadata about it. This is one we see a lot, weirdly, in some of these terrorist cells. They have figured out, hey, I can send pictures. So here's a picture over here on the right, and here is our message, the secret password, and it's hidden inside of this file. And those files have millions and millions and millions of zeros and ones. And our computers are really dumb again. That's all they can store is strings of zeros and ones. How do we find out that those strings of zeros and ones are containing some other message? Because maybe this message is, hey, on the 21st of February, we're going to attack the Omaha World Press or something. We don't have any way to know. So this is actually a really interesting way to hide data, and we're going to show you how we can do that. We can even make it more obscure because we can hide that data across multiple images, multiple songs, multiple different pieces of media. And again, one of the advantages of this is it can be very obscure, but I have to have access to the file. So I have to be able to get those files, and I have to know a couple of passwords at least. or a key that we've created. It's really interesting. We can hide a lot of horrible stuff in there. So we need a couple of terms so we're all on the same field here. So encryption is really just that idea of we scramble data. And if encryption is scrambling it, then decrypting it is unscrambling it. So we take our data, we put it in, we take our data and we take it out, and now it hopefully is the same. If our algorithms or our computer programs or our methods are sound, we're going to get the same thing out that we put in as long as we have the right key. So that item we're going to send in there, we typically call plain text. Yes, it doesn't have to be just text. It could be other data. It could be videos we're burying in there, whatever it is. But we call it plain text. That's that stuff that's unencrypted. It's our message. Hey, we're all going to meet at the mall tonight. That kind of message, it's there. Once we scramble it, and we have this message that we can't read, we can't see, we can't figure out what it is, that's called ciphertext. Well, one of the problems we have is we need to be able to send that data scrambled. But a lot of times we find out we're sending this data and it doesn't have any encryption in it. So in other words, anybody able to listen to our communications or they've got something on our network, they'd be able to see what we were trying to type. Great. So you're going to see some terms in here. We talk about end-to-end encryption. We even now encrypt data inside of our computer so that the data coming into our computer is encrypted, the data that's stored on our hard drive is encrypted. So all of that is inaccessible unless you have that key to the house to get that. Those keys are mathematical models in most cases. So it's a string of digits. It's a value that equates to something else. So one of the things we need to deal with is we need to deal with the fact that our computer is really dumb. And so one way we know that our computer is really dumb, we know the alphabet, right? Our computer doesn't. You will need this sheet on Tuesday again when you come in. So this is something we call ASCII. So I've got to set this up a little bit. Got some sheets here. So every value we type on a computer keyboard has a value. And so for us, if I find the letter C on here, I can see that it's got a lot of different values. The ones we're going to worry about is we're going to worry about the decimal value for now and the binary value. So decimal says, hey, that's 67. Well, if you had the entire chart of this, there's actually 256 different characters. So notice we start with 0. And so some of these are not characters like you're thinking, but they're also commands. So like null, carriage, return over here on the far left. You have all your symbols. You have uppercase and you have lowercase. And then we've got a whole bunch of other symbols and things that are from this 127 all the way to 255. What happens and why we chose 255, so 0 through 255 is 256 different possibilities. That happens to also be the same size as something called a byte, B-Y-T-E. A byte is a possibility of 0 to 255 possibilities. And it's 8 of those zeros and ones. And so we're going to look at those. In fact, if you look at the binary on there, notice they're neatly arranged in groups of 8. And it's really the first thing that's useful on our computer is that idea of a byte. So 2 to the 8th power, or 256, is the number of possibilities. The computer always starts counting with 0, so it's 0 to 255. And we're going to see that theme in here when we start talking about IP addresses and all kinds of things, that byte becomes very, very useful. So a lot of our encryptions are based around what we can do with that byte, with those zeros and ones. So one kind of thing we can do is we looked at that substitution. And when we were in grade school, we thought it was pretty clever to just have A as 1, B as 2, C as 3, right? But we can also do something called a rotation. And a rotation rotates data around. So if I rotated using what's called ROT 13 or rotation 13, the entire alphabet is rotated 13 steps. So one way I always think about it is if I had a big chunk of numbers in this hand and a big chunk of the letters in this hand, and I spun them 13 steps, that would give me a way to do that. I could change A to N, and they would rotate around. So it's a little more sophisticated, but it gives us a very similar response. So there are even some tools available, and you can find all different kinds of these. So this is ROT 13, and this is what it looks like because it rotates those letters 13 spaces. So if I take this, let me see if I can copy and paste with this. So, come here. Notice when I put it in the other side, and all I did was copy and pasted it, it's reversible. I took that gibberish over here, and I ran it back through that. So it rotates through only those 26 letters. It doesn't pay attention to capitals or anything. So is that a particularly sophisticated cipher? No. If you wrote one of those and you were writing love letters to your classmates, you would get found out pretty quickly, you think, right? How could we figure out this code? If we had a whole lot of it, what would be a kind of a giveaway? What was that, Hannah? Did you say frequency distribution? You're like, no, I didn't, but I should have. So, in our language, in English language, we know that some letters are far more common than others. And what we can do is if we had a whole lot of that gibberish text, we could do a frequency analysis. In other words, we look for how many times different letters show up, and we could then match them to the patterns we know about the English language. And so we could say, oh, I'm pretty sure that, I don't think we have a T in there, do we? Oh, the G is really T because of our frequency distribution. And then I can count letters and go 1, 2, 3, 4, 5, 6, 13. And I could rotate each one 13 characters pretty easily. So it's a first try, and we actually use some of those ideas from this. But this idea has been around for thousands of years, thousands. And in fact, it wasn't even in English when they first started using this as a cipher to try to hide communications. So this is one way we can do it. And you can find tools online. You can write a Python program really quickly if you wanted to shift those. Because all you're doing is literally rotating it around in an imaginary wheel, if you wanted to think about it that way. So you can also do So here we have another website I grabbed, and this one allows you to change some of those. So you can add uppercase and lowercase and ROT 18. You could rotate it 47 times, and it's got some symbols included in there. So there's a lot of different variations of this. But it's probably not strong enough to keep that secret military secret, or who your crush is, or whatever you're doing, to keep that secret. Somebody will be able to find that out pretty quickly. But it's a beginning. We kind of get that idea that we're going to cipher. So again, here's our cipher, and here's our ciphered text. The other thing that's kind of a giveaway with this, or a problem with this, do we still have the same number of words in each little grouping? Yeah. And if I see a whole bunch of three-letter words, what's the first thing I'm going to think those are at the beginning of a sentence? The. So it's not great. It's a beginning. If you were in second grade, this might be really kind of handy to confuse your friends. But we're going to take some of these ideas and make them more sophisticated. Let me move that over. Get this out of our way. So that cipher is how we do it. Not Beverly Hillbillies style of ciphering. Well, I guess it kind of is, but we're trying to look at what we can do. So that typically is called a substitution cycle or cipher. We're going to take one item, substitute for another. The key then in this is how many letters we're cycling and how big that wheel is. The one we use a lot is this thing called an XOR cipher. And XOR stands for exclusive OR. We're going to get to play with it. So what I would ask for you to do this weekend, Saturday, you're sitting there, it's raining, you can't go out, it's freezing, it's horrible. In our class, there is a video. I don't know if I can make this small over here. Hang on. Oh, no. There is a video. Let's see if I can get there. Thank you, Cengage. There we go. Down here towards the bottom, there is a video. I would encourage you, it's only about 5 minutes long. It's old, it's interesting, and it's weird that he's using a lot of yellow sticky notes. But we're going to do the same thing, and we're going to actually use an XOR cipher and practice with it. So make sure you've watched this. It will be fascinating to you, I am sure. If you really get bored, I love this guy up here that always shows, when I play this one, up here in the right-hand corner, is something called AES that we're going to talk about, Advanced Encryption Standard. And this is a British mathematician, and I just love the way he delivers content and material. So I watch a lot of his videos. So 1 o'clock in the morning, I can't sleep. I'm on YouTube watching stuff just like you guys. Only sometimes I'm watching weird nerd math videos or something. So all right, so we have some terminology. We know what a cipher is. That's how we're scrambling it. We know what plain text is. We know what ciphertext is. That's after it gets scrambled. So we're starting to get some terminology down. So this is really the same idea. Here we have a memo, confidential memo. Layoffs at this store are going to begin now. That's probably not one you'd want every employee to know, right? So they used some kind of tool so that encryption, and they have a key, and they created that ciphertext. It went to the user, whoever it was in the company. They had the key, and they said, all right, I'm going to unlock it. Now I know what that message is. Well, we do something similar all the time. If you've gone to almost any of the bigger hospitals, they give you a portal so you can go see your own lab work and test results. That's that same idea. I won't want everybody to know what my brain MRI looked like. not that I care, but there are data that's probably personal in there. So go around. We have to have some way to do it. Does anybody see a flaw with this yet? Any flaws you can see? We can make that key pretty tough, and we're the only ones that have that key, and these two people are 600 miles apart, let's say. Is there any flaw that anybody can see in this? Everything I send to somebody, I have to get it there, right? How do both of those people have the same key? Did I send that in an email? So this can be very tough depending on what process you use. The problem is, how does everybody know this key? And if I send it to Bob, how do I know that Jim didn't also get a copy? So this is what we call symmetric encryption. It's encrypted and it's decrypted using the exact same key. Well, that makes sense in our brains. I will say it's probably the easiest method in terms of our brains to process. So everything in here. So substitution cipher, that's our alphabet, A through B. There's our rotation, so we're rotating around that. Here's our XORs that we're going to go into great detail. And if we combine some of these together, so we substitute in letters, and then we rotate them, and then we do an XOR. Well, now we've scrambled that data even more. And you'd have to know the key, and you'd also have to know the processes that we use to do it. Because if you did them in a different order, or you were trying to use ROT 15 instead of ROT 13, so some of these standards that we talk about, so AES is one of them. One of the standards our military and other people use. One of the things they do is take very basic operations like this, and they do it multiple times, over and over and over again. So AES, for example, you may scramble that AES data 14 or more times, depending on how strong of encryption you need. So to unencrypt it, unless you have those pieces and know the exact policy to get back, that data is pretty well gone. So that's very similar to when somebody gets on your computer and you get a ransomware. It's hard to get that data back. You don't know what went into getting it there. You don't know the key, and there's so many possibilities that you could try every different key you could do, thousands of them a second, and it would take you 1,000,000 years to do that. We are not going to torture you with a lot of math formulas in here yet. You looked happy, and then I said yet. So one of the things that almost all of our encryptions need today is a random number. Something that's truly random, something I can't guess. And so your computer, in most cases, has some way to generate what they call a pseudo-random number. So that number in your computer, we call a pseudo-random number. There's a program, there's some kind of a clock in there that's spinning, and it stops and says, here's a number. How we seed it, or how we start that sequence, we know can change that value that the computer generates. We call it a pseudo-random because it's not really a random number. We have a process to generate it, and if we know how Intel or AMD set up that process, we can use timing attacks and actually make that much less random, those numbers that happen in there. So some companies have tried to create chipsets that are very, very or more random than others that can help in our encryption, but that software takes that number and uses that as parts of a key. So it gets little pieces of that and says, here's my random key. And we're going to do a lot of things with it, but if it's not truly random, then we have a problem. So we try to get as close to truly random as possible. We know that we aren't, and so that's one of the limitations we have in our encryption now, is we don't know that things are truly random when that computer generates them. Well, there's a lot of times we find that there's weird little glitches like this. So, we need a couple of things. And so our book calls this diffusion. So one of the ways we diffuse things, if I type a message that has 10 words, it would make more sense for that message that comes out the end to maybe have 1,000 characters, whether you put 10 words in or 20 or 30 or 40, so that it's not able to be recognized by just like our cipher was earlier, where we could see the individual sentence structure still. We want to spread that out and confuse that as much as possible. We don't want to know how many characters there originally. If I know how many characters get sent, then I possibly have a security issue with that. We also want it to be confused. So that key should not in any way relate back to my original cipher. Here's the example of that. If you put in the phrase password for a password, that's not very confusing, is it? No, you want something that is not hard or not easy to guess and not able to find really easily. So, all right. So what can cryptography do for us? So confidentiality, it can say, well, only those people that were authorized to see it can get this message. It can also make sure that the message is in its pure form. It's integral. It has integrity. It didn't get changed somewhere along the way. You guys have all probably played the telephone game where you whispered a word into somebody's ear and it went through like 5 people. That's what you're fighting against, so that message is the same. So it also says through authentication, it says I know who the sender is through that authentication process. It also says that we can prove that you did an action. Oh, could stand up in court. And we really want to obfuscate or make as unclear the meaning of that message. So that message needs to be all scrambled up. It's messy. It doesn't look like anything until we unencrypt it. So we actually even have a whole idea that we can make things secure because outsiders aren't aware of it or how it functions. So Peru, for a long time, operated on that model. So before the internet came around, did anybody know where Peru was at? No. If you would have asked me in 1996 when I first came into this area if there was even a college here, it was so obscure. I'd stopped at the Casey's. I had no idea there was anything past that. So obscurity has kept a lot of smaller businesses, places like Peru, safe for a while, but unfortunately that's going away. And when we think about our codes we're going to use, we also want to have that so it doesn't have any intrinsic meaning. So here's our shortcut to that. So authentication. Are there messages we'd like to make sure are authentic? Yeah. Think about that CFO in Lincoln or in Omaha wanting to send money to China. Wouldn't it have been great if he could have proved that message actually came from his boss rather than just wire $13 million? Yeah. So there's a lot of times we need that ability to do that. So I've kind of hinted at this. We really need to encrypt our data when we're using it. So that makes sense. When we're taking some action or sending data out from our computer, hey, that makes sense. We need to encrypt it. When we're using it in some way, yep, we need to encrypt it. But the weird one, and we don't think a lot, is that idea of data at rest. So it's stored on our hard drive and our computer's turned off. Well, who's going to get into that data? Well, if it's encrypted, nobody. But we have some examples of people not realizing you can encrypt data. So one of the people that my girls and my wife raced BMX, and at the BMX track in Omaha, there was a guy that he'd been around my girls, he'd been around all these kids out there, friends with all the people at the track. Well, he wasn't apparently as smart. He took his computer in to a service shop in Bellevue, and when they tried to fix it, they immediately went, holy cow, why is there all this child pornography on here? Now, I'm not saying that had he scrambled that data, that would have been great, but it was a way we can hide our own data. In this case, they promptly arrested him. He lost his job at a school where he had been for about 25 years. So, in this case, that scrambling would have prevented him from going to jail, wrongfully so. But if it's our company data with all of our sales figures, our finance numbers, make sure that it's encrypted. Make sure that it has some way of being safeguarded. If you're taking backups, and a lot of companies do that, they back up to flash drives, they back up to a DVD in some cases, and then they take it and go, well, I'm going to go put it in the bank. And you're driving along with that data in your car, and your car wrecks, or somebody runs into you. Now every student piece of data, because we didn't encrypt that backup files, it could be very costly. And so we have to think about, we want that data scrambled as much as we can. If you're out working somewhere and you've got data on your computer, whether it's personal data or company data, and that laptop disappears, you go through an airport and it gets stolen. Well, if that data is encrypted securely, nobody else will be able to get into that data, and you'll be okay. So I'm going to check on my Windows 10 thing here, see how we're doing. Aha! All right. So I'm going to stop here for a second. Is everybody else got to this stage? No. You have, yours is still, how much, does it have a percentage? 8? Man, what kind of podunk slow thing did we give you? Holy cow. All right. Yours is done? You're done? No. You're done? All right. I'm going to go ahead and we'll go through it again, but you might spin around and watch one of them that, has a faster connection than you. So we have some oddities in some of this in here, and I think you're on a last link there. All right. So we've stored this file, and it's stored here in Documents. I don't need to do anything else. I don't need to create a DVD burner. All right, now it's going to close and clean up. I'm going to close this out for a second, everything. So I'm going to look here and make sure it's in my Documents. And yep, there's something called a Windows ISO file. In this case, it's 4.7 gigabytes for this version. Holy cow, that's a lot of data. All right. Well, I've got my installation file and I've got my framework. Now I need to connect them together a little bit. So I need to go back to Oracle VirtualBox. And actually, Destiny, you could do this step up to the point where you got to point it at the ISO file. I'm going to click on this thing that I think looks like a Reese's. Every time I see this, it makes me want to go to the vending machine and find a Reese's. All right. So we're going to call this Windows 10, and then I'm going to put behind it your name. So I just became Destiny, even if I can't spell your name. All right. Here's where I'm going to run into an issue, and I'll show you what it's going to be here in a second. Okay. So on this particular computer, I know that I have an issue. And the reason I know I have an issue, I downloaded a 64-bit version, right? But everything in Windows is 32-bit. And when I see that, that tells me that my VirtualBox has an issue running 64-bit operating code. What it actually means is that in the BIOS, which I have no way to record, so I can show you guys in class, but we'll have to find a way to figure it out. Somewhere in the BIOS that was not turned on for something called virtualization. So when your computer starts up in that very first splash screen and you can set up items before Windows starts, it tells me that there's an issue with that. I'm going to go ahead and create the container anyway, and then I will come back and I'll show you how we can fix this. So I want Windows, and I really want the 32-bit, and it should actually pop that in for me. The other thing I might put in here, if I'm going to put a password in here, because I won't ever remember it, I'm going to put my password right up there. And that way when I use this, I'll know what it is. In here, that's fine. If you did this at work, I would yell at you and get you fired immediately. So next thing I'm going to do is click Next. The amount of memory we want to use. So Windows really wants 4 gigabytes or 4096. This scale tells me how much memory is available on my computer in total. And if I stay in the green, so as close to 4 gigabytes and staying in the green as I can get. The hard drive, so we're not going to physically attach a hard drive to this, but we're going to create what's called a virtual hard drive. So I'm going to leave this at its default where it says create a virtual hard disk. I'm going to leave it as a virtual disk image. I'm not going to change that default. I'm going to use what's called dynamically allocated. And here's where I'm going to store it. The size of the drive, everything looks good, so I'm going to click Create. When I did this, now I've created a folder that's going to run, but I still haven't installed Windows 10. I have not gotten to that point yet. So when I double-click this to turn it on, we're going to start our virtual operating system. Comes over on the other side, of course. Well, the first thing that's going to pop up, it says, oh, I'm going to have some kind of an error. And so in this case, I don't know if I can stretch it out here, failed to open a session. And what it really means that VTX is disabled in the BIOS. So I've got to go in on this computer, restart it, change a setting in the BIOS, or the very first thing when that computer comes on and it's got the black and white text and it says to get into setup, hit here. So I've got to do that before I can do anything else. So I'm kind of stuck right now. So I am going to stop my recording and save it before I do